Hope everybody's doing good tonight. Shelly, Dennis, Christy, Phantom of Moonbeam, there's my favorite name. 210-3. Missy, I think I already said hi to you. Maybe. No? This first time. Yeah. Christy, Dennis, Shelly, Jamie Jones, Dorothy, KB, Dan the Man. That's right. Sea Glass Love. Yeah, I'm doing okay. Thank you for asking. Hey, OU812, Jeff, Hummingbird, LP, Michael Hart, Rebecca, Margie, Taylor, Alyssa, Sparky, what's up, bud? Gail, Christopher, Little Too Spicy, Antonio, Robin M, what's up? Back at you. Back at you. Tracy, William, Sid, what's up, man? So, hi to everybody. I don't know if I've seen any, Tony, if I've seen any mods in there yet or not. You know, hopefully they'll stop in, at least one or two of them. We'll see. We will see. Yeah, Andy, that's cool. Cool. Go for Sparky. Hey, Sid, I'm gonna make you a mod, okay, man? If that's okay. You and Sparky. If you guys don't want those wrenches, just tell me and I'll take them away. It's no big deal. You know, everybody pretty much knows my, yeah, you'll pretend. Back at you, Sid. Yeah, don't feel like you gotta be here all the time, guys. I just, when I put the chat away, I want somebody in there in case that can actually, you know, click a button if it needs to be clicked. When I'm not looking at it. So, Sparky and Sid, I know they both know my chat rules. So, they've been along. Well, we talk over on Mark's channel, Mark Pyers, Real Talk, all the time. Plus here too. So yeah, BYG, exactly. Oh, you watching? Yeah, Tim. That's you know, they're still hot spots. They're not going away. And what's kind of crazy about it is, you know, it didn't. If you go back like a year or two, you're not going to see any of them. Oh, you're buffering? Is anybody else buffering besides Erica? Let me know. If you are, I'll try to shut down some of my other stuff. That way it doesn't mess with us. Okay, no buffering? Okay. So yeah. Sometimes it's my end, sometimes it's whoever's buffering, it's their end. If you are buffering and I tell you it's not my end, you might just reload. If you reload, a lot of times it'll fix that. So, just hi to everybody, and yeah, okay, cool. I'm gonna go ahead and put the chat away so we can get into this, okay? Alright, Schumann resonance, obviously, that's a spike. That's a big spike. Well, let me say a long duration spike. That's more of what that is. So if you've been feeling a little bit crazy today, a little bit more than normal, ringing in your ears, headaches, heart stuff, all those kinds of things. If it's minor, you can have major symptoms with this, but usually the telltale sign, it starts off minor, you know, but don't ignore it. If you look at this and you think this is what's causing it, and you're still experiencing it, go to the doctor, okay? This is the best advice I could give. There's always underlying health issues in a lot of the cases, but this does play a part in the diagnosis a lot. Anybody with heart issues and stuff, believe it or not, probably most people with heart issues know about this tool. You know, the doctors are telling people now because it's that significant. Okay, let me refresh this page here. Okay, so you can see here, guys, where we had, you know, a couple more flares and Ccme'S behind it. So there's a couple more. Now, I don't think that this one's coming at us. We'll take a look at it, and I'll explain why I'm saying that. But there's a lot more other stuff going on in the sun too right now. It's very active on the sun. It might not be big stuff, but stuff is, well, I'll just show it to you when we get there. Geomagnetic activity, it dropped out again really low. It bumped back up, but it's not much. As long as we're staying between 2 and 3, we're fine. Again, guys, if we're at, like, say this first bar here and these 2 bars ended up being 0, that's a full day of 0 reading geomagnetically. So when that happens, they issue a cosmic ray warning. And again, that's for people that are flying most of the time up towards the up towards the poles. But and then all it takes to get it out of that is to get one of these to come up to 1. And usually they will, erase that or discontinue the warning. But the conditions usually seem to follow for about 24 hours. So that's why I bring that up. But you can tell flare action. We wouldn't know if we had CME action hitting us yet because it would take 3 to 5 days to get here. So that time frame hasn't elapsed. I'll give you a quick little view on this one right now. You guys can kind of see already that I'm going to be talking about some activity here in a minute. That's definitely that's a substantial sunspot. We got another really active area up here starting, incoming. What I think this one is, I think this is the one that exited about a week and a half, 2 weeks ago on this side. And it survived, and it's coming back around. Now, I find on this particular filter, I find this interesting. Right there, okay? Yeah, it's not you don't usually get right angles, guys, okay? And that's pretty much what we're looking at there. It looks like a triangle from our view, but it's not. It's like behind here that you could pretend the line gets drawn on out, and it would be more of a rectangle or a square shape. But you can tell that nature doesn't do things in straight lines. It just doesn't work that way most of the time. So when we see that kind of stuff, we really stop and look at it. This coronal hole here was the one that was over here yesterday. It is substantial. It's starting to exit out, but it's still going to be a few more days, and my guess is we're going to get some solar wind from that here in about 2 days, 2 or 3 days. Here is some more solar, some more coronal holes. This one over here, remember the parallax effect. If you're looking dead straight on to a sphere, things are going to look smaller the further to the side that you get. So the more this one comes closer to the middle, it's going to show its true size. And so what I'm saying is that if that stays the same size, it will be bigger when it gets here. So just don't be fooled by that optical effect that we see. We live in a 3-dimensional world. This is a 2-dimensional thing that we're looking at. So that's why. The northern coronal hole there is kind of wide open. So is this. They're all kind of connected. And again, I have to say, I've seen coronal holes. See where I just drew right there? I've seen coronal holes take up that much of the sun. So, don't freak out over this stuff. It's just going to be, increased solar wind and stuff. We could get into a storm level, who knows, but we'll have to wait and see. ACE data. Pretty par for the course here right now. Nothing too crazy, okay? The phi angle is kind of jumping around a little bit. The polarity of it's starting to move, back and forth. And typically when it does that, we do see little hits on our magnetosphere, but it's not usually that substantial. Every once in a while, though, we'll get one, especially with like planetary alignments, and when that happens during one of those, it seems to hit us a little bit harder. But the BZ, right now it's a negative right here, just these last few readings. Actually, guys, we're here in time on this graph. What's happened here is that's the loss of the line of sight for the satellite, so it can't transmit data. So we don't have like the complete updated real time on this yet. We won't for another few hours. But that's why you see that. But the the wind speeds back up to what I would consider pretty much normal, just right in the middle. Temperature, same kind of thing. Now remember, we look at the the range over here, and that's okay. If you got 200 kilometer per second range difference here, that's okay. It's about what it should be. When it starts getting up to 800, or if it closes down between like 2 and 250, yeah. Anyway, you get the density, same kind of thing. All this stuff is telling us that stuff is actually pretty quiet here on Earth. Doesn't mean it's going to stay that way, but that's what we're experiencing right now, other than the spike on the Schumann. Now, okay, yeah, so, yeah, that's exactly what I thought I was going to see. Anyway, we're right here in time, so you're seeing this bump right here. It's probably from that coronal hole. I would almost bet, because we've been connected to it for about a day and a half to 2 days already. So that's where that's probably coming from, unless there was some sort of a CME eruption that we didn't see. That happens. They call them stealth CMEs. They usually end up being pretty small, but they still do hit us. The velocity, obviously, is going to try to do pretty much the opposite of the density. That's just what it does. Our electron flux graph is starting to try to go back to normal. I'm not sure why it did all this. We were having some issue. You can kind of see where it's trying to curve, but all this, maybe I got a setting or something here clicked wrong. I don't know, but I've not seen this one really look like this that often. The magnometers, this looks pretty normal. You get a little spike about right there, but not much of anything. Auroras, look at that real quick. Again, you're not going to see much on this unless we're getting, solar weather, space weather. And we're not. We are getting a little bit of stuff, but not enough to really. Now, something else, you guys remember last week or earlier this week when I showed you guys those auroras, those pink auroras and the red ones? We were getting like no high-speed solar wind at all. It was moving slower than normal, but yet we started seeing auroras, and the reason why is because a lot of the cracks in our magnetic field were being exposed, and it was still coming in. So that's what happened with that. And again, with slow wind speed usually comes high density, and they've already come out and said that density has a bigger effect, or as big of an effect as the speed does. Here's our magnetopause. Let me go down through here and click play on these real quick. I'm going to X out of this one too. Well, X out of this one anyway. Everything alright in there, guys? Okay. I just want to make sure everybody can hear me and stuff. Here's the Australian model. Actually, I'm going to go back to the 18th. It was trying to show us some stuff from the 19th. We got like an hour or two on the 19th already on this model. Again, this is our magnetopause magnetic field. Sun's over here. I like this one because of the simplicity of it. It's not trying to show you anything crazy. It's just simply showing you where our magnetic field, our bow shock, is positioned, and it shows you the effects of solar wind hitting it, and this is what happens. Here's all the satellites that we pay attention to anyway. Obviously that's not all the satellites out there, but that is the satellite orbit line. They try to keep it there, and the reason why is because it's in that perfect position that the gravity from the Earth and the gravity from other objects are keeping it in that spot. That's why the satellite orbit line has to be where it's at. You can get like a near Earth satellite or orbit line, but the majority of you got to make adjustments to your craft, so that's why. But we look at the speed and the density; it's confirming what we already seen. So, okay. I'll tell you what. Before we look at that, let's just do this real quick. I'm going to start off on like the 15th here. And I want you guys, well, wrong one. Okay, I might even go back to the 14th. Alright, this is when we started seeing the Ccme'S and stuff. It might have even been back further. Yeah, see, they're on the 13th. End of the day on the 13th, we get a Cme. 14th, two of them, three of them actually. Two of them on this side, one on this side. '15th, that was the one from the one I just showed you, and then you got this one. Okay, next one, 16th. This is that flare, I think, pretty sure. Yeah. '17th. So as you can see, you know, 17th went kind of quiet a little bit, not much, but we're still seeing some activity yesterday, and then today. This is what we get. Boom. Two more. Okay, that's what we're getting right now, and it kind of showed it on the solar, on the X-ray. So it was, part of that was a flare, and then there was a Cme that blew off behind it. So that's what you're seeing there. So, you know, guys, I mean, that it's that one sunspot that we, you know, didn't hardly do anything when it was crossing in front. And as soon as it got over here, it started doing stuff. And, you know, if you go back, like I just did a minute ago, let's just go backwards now. Notice where the majority of the activity is. It's all on that right side. Now, we get one or two over here, but the majority of it's over here. So then you got to ask yourself why. Because this sunspot that was cresting over here was bigger than this one. And, you know, you ask yourself why, and then, you know, we look at stuff like this. Let me show you. What's it? Where did it go? Where did it go? Okay, I wonder where the heck it went. I must have put it in a funky folder somewhere. Anyway, it was the pics I showed you guys from, well, I think here's, yeah, here. Okay. So you gotta ask yourself, what the heck? And that's on that same side. That's where all the activity was going on. So, you know, take that for whatever it's worth. But it definitely activity on that side. Way more than what we were seeing on the other. So, just like we do every time, we try to figure out why. That is one explanation for it. It's not the only, let me say. But, you know, I do think that sometimes planetary alignments, like I said before, and just overall chance sometimes will have that happening. But when we put that through the software Scott uses and we see stuff like that, it does make you wonder what's going on. Why is everything over here on the same side that we're seeing those kinds of things? So, yeah. Here's the CME tracker. Now, this did update, okay? You can watch up here, I'll say the 18th. So, that CME we were just looking at, excuse me, is not coming at us. Okay, we're right here. So, it's going this way. But, yesterday I showed you one too, pretty much in the same position. And the reason why, it was from that flare, but they came from the same sunspot. This one actually is a little bit more further towards the backside. Why? Because that sunspot was still rotating around. So the second time it blew it out this way. It's not coming at us, but we did catch some X-rays from it. Because, you know, like I said, X-rays go out in all directions. Not just specific like plasma. So, here's the official coronal hole. And for the life of me, I can't understand why they're not, why they don't have that one circled. I mean, that thing was pretty substantial. In my mind, there was no doubt that the atmosphere of the sun was gone right there. So, you know, here's that big sunspot on this particular one. It's a stereo A. Now, you guys seeing that? Watch. Boom. All sides. And then that, what you're seeing here, is that last CME. Solar flare CME. Now, I know, because Earth's over here, guys. Actually, it's kind of here. Remember, stereo A is over here, so that would put Earth right here. If you want to look at Y, let's go back to this. Here's Earth, here's stereo A. So that's the difference. The one I just showed you, we're looking from this satellite looking right at the sun. That's the angle we're looking at. This is slowly creeping towards Earth on purpose. That's what they're doing. They do that on purpose. It used to hang out almost 90 degrees. So it changes its field of view. Right now, it's looking like this direction. You take that same shape of V and pull it over here, then you're looking at this direction. So it changes what you're looking at, the direction of it. It's important to know. It's the geo-electric field map. This is the solar weather's effect on our electrical grid. I did notice something a little bit strange on here. Let me show it to you. Back that off a little bit. I don't want to call it strange. It's just something I noticed. You're gonna see like the energy hit here, and you can physically see it go that way. Okay, first you see that, right? So whatever solar weather we were getting, you can see how it's more intense right here. It's almost like there was one of those cracks. Because it's not up here. It's there now, but the intense part of it's right there. Now, let's wonder if I just didn't go past it. Let me see. Nope, there it went. You're going to see it. It's going to start here, and it's going to go that way. See that? And we're getting little flashes. Those are quick little bursts. A lot of times those are from X-rays. Okay? Because they come and go that fast. They get here in 8 minutes. So, pretty fast. Here's the earthquake model right now. Again, no big ones yet. It's getting a little bit, it's starting to get a little bit concerning, just so everybody knows. When we don't get, sevens, we don't get those that often, but we should be getting them, every so often. And we haven't had one for a while, let alone a 6. You're not going to find a 6 on this map. It's been like that for a few days now. There might have been 1 or 2, like a 6.2 and a 6.4, I think. But something else I like to show people, you see the amount we got here, right? That's not real bad, but it's not great, okay? Watch this. All I did was I switched it to all magnitudes. So that's more indicative of what we actually had as far as numbers. Now strength, yeah, we're not going to pay much attention to a 1.7, right? Because it's just, we would pay attention to the location, because look at that one. Look where that's at. That's at Ridgecrest. We always talk about Ridgecrest. Right there. So when we start seeing stuff like that, we start seeing swarms. And I've been asked, why don't we see swarms over here? Well, because we're not in control of those tools over there. That's why you don't see hardly, part of the reason you don't see anything hardly ever come in from China, come in from Russia. You think that they're exempt from earthquakes? No, they just don't let us know when it happens, and we don't see it. We don't get to see that kind of information. They're that secretive about stuff. I often wonder who's doing the right thing there. Makes you wonder. Makes you wonder if you're on the right side, doesn't it? Who knows? But anyway. So, let's go back here to, I'm going to take you over to spaceweather.com real quick. Let's get that off there. I want to show you guys something here real quick. Well, you know what? Before I show you this, let me... I wanted to show you guys something that Mike and Cindy, they did a show, and they were talking about something Mike had sent and asked my opinion on it. And I just want to show it to you because he did a good job reporting on it. I think is it here. Yeah. Okay. Now he's talking about something I was talking about too.
Evolutionary Energy Arts family.
Okay. The meteors, right? How they've been adding because they didn't see them. And I would encourage you guys to go over here and check this out. We'll listen to him here for a minute. He sent me this asking my opinion on it, and I gave him my opinion, and he reiterated it during his video. So, but everything that they talk about around this is possible too. It doesn't have to be what I said. But I do think that what we're seeing there is the Aurorid meteor shower, but it's upticked. And he makes a good point because we're seeing more and more.
Screenshots before. It's busy out there. It's really, really busy out there. Impressions?
I can hear it. It's strange. When I look at it, I hear it. I hear the...
So, yeah, that's Mike and Cindy at Evolutionary Energy Arts. Guys, go give them a sub. Go check them out. EE Arts, that's their backup channel. I think they're broadcasting more on this channel more and more. I think their main channel kind of got attacked a little bit. So, they have two channels. I usually have a link in my description anyway. I'll put their link in there again. But that's what this is, okay? And he said it just right because it is most definitely upticking.
I hear the
okay.
pinging.
We're getting more and more activity, and yes, we're in the Aurorid meteor shower, the tail of Halley's Comet that we pass through every year. But this does seem to be more, even outside of that. We're not supposed to peak until the 20th. So, if we're seeing this kind of stuff, and the other possibility is cosmic rays, but this looks a little bit like a combination of both. I will say with like a meteor or a asteroid or something, a lot of times you'll see more of a speckled debris trail, I guess you could call it. With cosmic rays, sometimes they just appear as lines. When I was watching Mike's video there, they were asking him about this black, what looks to be like a black beam coming out of the sun or a shadow. What that is, that's the arm in front of the camera that holds the occulter. Okay? That's why that's always there. Now, if you want to vet that out and prove what I just said, you can go back in time on the same tool and you'll see this line exactly 180 degrees this way. Why? Because they flip it to keep one side of the lens from being exposed to all the elements all the time. Basically, it's their attempt to keep the lens from getting scratched as bad, increase the life of the lens. So they flip it every so often. So sometimes you'll come over here, and they do it months apart. It's not, and sometimes years apart, I think. But it'll be here, and then it'll be exactly 180 over here. So that's a part of the camera. It's holding this occulter. Okay, so that's what you're seeing there. At least that's what they say. Something like that. I don't know that it would matter if it wasn't. I don't know. I don't see what they would be hiding in such a small area, especially when they flip it exactly 180. With that being part of it, I really do think that's part of the camera. You can go look at the schematics on the cameras, and you'll find that piece. It's there. Sometimes they're even internal. The lens will be internal. And they do that to protect it. It'll be just like reset on the end of it. Like recessed in, like back towards the middle of the tool. And this will be actually like either outside or inside, just holding that. That's all it's doing. But again, is that exactly 100% provable? Well, it kind of is by showing the schematics of the camera. But then you always have to throw in the fact that they could be lying, all that kind of stuff, right? But I do think, my personal opinion is, yes, that's part of the camera. As far as these lines go, I told Mike exactly what I thought it was. I thought it wasn't like an increase in meteorites from the Aurora meteor shower, but at the same time, it could be cosmic rays. It could be a whole lot, beams getting fired, who knows, right? So, here's that sunspot, and it grew it increased like double or 4 times its size in a day. But what I want to show you guys here, well, you guys can go read this too. Tadpole sunset. You guys see that? Ain't that cool? That's just a cool article to go read if you guys want to check it out. But what I want to show you guys here, we've been talking about this, right? These near-Earth objects. Just from what I talked about yesterday, and Mike and Sydney even talked about this in their video, they added more. So, it's crazy. So how much of the sky are we missing? And why are we missing them when they're this close? This wasn't there yesterday, guys. The 0.4 was not there. The 0.5 was not there. Alright, we had a couple of them up here on the 17th that it was showing. The one that this 0.4 we actually talked about directly. So, then the next question is, how big are they? How fast are they moving? Again, nothing really crazy big or crazy fast, but still, they're not seeing these things until they're right on us. And let me say this, though, okay, first. On the 19th, we got one here coming halfway between us and the moon. 0.5 lunar distance. But look at its size. 2 meters. Okay? So get a meter stick, put 2 of them down side by side, and look at it. It's roughly about 6 feet. I think a meter's roughly 3 feet, right? Like a yardstick. They're almost the same size, but not exact. So if you do that, that kind of gives you an idea how big that rock is. It ain't very big. That one is not big at all. If that thing entered our atmosphere, it'd get burned up in a heartbeat. The majority of these do. Now, when we're talking about something like 38, or I've seen 50s, 55s, I've seen them up in 100 over here, okay? Yes, if those things get captured and come into our atmosphere, sometimes they do hit the ground. We all know that. But the chances of this happening is kind of nuts, So my question, and why I'm even saying this, is look on the 21st. 0.1. We got another one coming within 0.1. One tenth the distance to the moon. That's close. Okay? They reported 30 fireballs on the 18th, which is about normal, about what they had been doing. So I'm going to take us back to the 17th, and I'm going to show you that graph again. Okay, where's the 0.1 on the 19th? Oh, it's not there. Imagine that. You know what I mean? So what's happening, guys, is they're not seeing them until they get really, really close, and sometimes they're not seeing them until they pass us. So you can go back here, like I said, they always preface the name with the year it was discovered. And 95% of what you're looking over here is 2020. Why? Because, number one, the technology is so much better, and we are looking at more of the sky now than what we did in the past, obviously. You know what I mean? We're just now, if we want to talk about the overall time frame here, we're just now starting to look for this kind of stuff. So I do think this is an uptick from a normal thing, but at the same time, it may not be as large of an uptick as what it kind of looks like. This stuff could have been happening since the beginning of time. And that's kind of what I'm saying. It's just now we're able to see it, and now, the biggest thing is now we're looking for it. We didn't even used to look for this stuff. So that's kind of what I'm saying here. But what concerns me is that they're not seeing these things until they're either past or the next day they're going to be here. That kind of thing. And oftentimes I wonder, why? But the sky is big, okay? We are just now, as far as the technology we're using, we're just now able to kind of really get kind of confident in what we're looking at and how many we're seeing and all that stuff. So you can probably look for the next few years, probably even decades, that this number is going to increase. Now, just like what we talk about with this global illness, we all heard the term flatten the curve. Well, listen, that's probably what's going to happen with this. At some point, we're going to get to a position that we are actually seeing almost everything that's out there. So until then, we're going to have an uptick. And then it's going to flatten out really, really slow. And then we'll have a baseline of what will be normal. Then we can really have a discussion about exactly how many's out there. We will know empirically if it's an uptick or if it's normal. But I share the same opinion Mike did on his video, that we are in a more active area of space. So it causes us to question what's going on. Because even without that meteor shower, this stuff still happens when we're not in a meteor shower. And again, would they tell us? Come on, guys, we know the answer to that. If something was big, it wouldn't be on this graph, I promise. We'd be like the movie Armageddon, where they panned across the world and everybody's going to their call of prayer, spending time with their family, because they just can't do nothing. You can't do nothing about it, guys. And, so what would, you wonder, why would you even want to know? That's I do. I want to know. That's why we do what we do, so we can make better decisions. That's why. But there's some people that live by the philosophy, I don't want to know that because, and unfortunately, I think sometimes, more times than not probably, they do. They don't tell us everything on this kind of thing. Because this could be very, very catastrophic if something was coming at us. Now, something else I want to point out. If they discover something back in 2007, well, this one right here, look, 2018. See that? 2 years ago. It's going to pass 16.4. It did pass 16.4 lunar distance. You go to the moon 16 times and a half, and you will be out that far. That's where that near Earth object was. Now, I know we're looking at that like saying near Earth. That ain't near us. Well, in the realm of space, yes, that's pretty close. Okay? But for us, yes, it's not that close, guys. It's really not. I mean, we're talking, millions of miles there. So, with that being said, that was discovered in 2018. So, take in consideration, what if their math was off? And as they actually will change the the distance, because most likely as this thing was coming in, it probably did change a little bit, the distance that's going to be between us, right? Because they're not there. They ain't like you can take a measuring tape and go out there and measure it exactly. They're using all kinds of different mathematics, but That's my point. If their math is off by just a 0.10, say for example, back in 2018 when it was really far away from us, and then that would put this thing, it could make it come closer, or it can make it go further apart. There's always mistakes. That's a lot of room for mistakes to happen. Okay, 2.5 years. Some of these I think were even 2017, 2008. Look, they seen an asteroid back in 2008, or a meteorite that's going to pass 17 lunar distance away. Well, about 18. But that was 2008. So what if their math was off just a little bit back in 2008, and that thing ends up, coming right at us? We just don't know. That's my point. 22 fireballs today. I would encourage everybody to go look at this every day, because you'll get a feel real quick on how active stuff is just by looking at these kinds of things. On this one here, they do show that coronal hole, but this is back on the 17th. I'm not sure why this is almost 24 hours old. They haven't updated this yet on their site. But they say we're in a, the neutron count's up, and that's what they're talking about there is cosmic rays. So we're in the high range right now, and that would make sense because the geomagnetic activity was 0 for almost a full day. Here's the sunspot. It's decent size, guys. So let me take you guys over here real quick, and this will be the last thing we do probably. So let me show you where these things are happening at here. Now, right at the beginning, you're going to see that the CME we seen, our flare, which also had a CME behind it. So watch over here. See that? That little ripple right there? See how much of the sun was affected? All the way from here, all the way up to here. From that one area. So that tells you, if you look here too, you got some pretty good energy going on. But watch this again. Boom. See how it just kind of ripples across? Now something else, look up here. Watch this. Let me, watch up here. You see that? It's right in here. You're gonna almost miss it if you don't know it's there. See that? The color difference is what you're seeing. That could have been a stealth solar storm. I don't know if any of that came off the sun. I can't say yes or no on that. I can't see it. Something happened right there. Okay? And if that happened right there, it could come at us. I don't know. So if you look at the rest of the sun, you're going to see activity there too. I mean, it's popping all over the place, guys. Now check out the purple one over here, the 211. We'll be able to see it real good right here. Remember, look up here. See that? So I'm not exactly sure what that was. Okay? It could have been just energy transferring across the surface. I don't know. Or it could have been a stealth solar storm. We won't know for 3 or 4 days on that, if that happened. But watch over here. You'll even see a blink of light. Let me zoom in a little bit closer on this one. Watch this thing blink. Right here. See that? That's a flare leaving the sun. I can't believe it caught it, just to be honest with you. We don't often see that. Because this is a time lapse. We get a capture, I think, every 12 minutes or something. Yeah, every 12 minutes. So this thing had to snap a picture at the exact same time that thing blew off the sun. Crazy, isn't it? So let's go over here and look at the 304. And again, guys, those are just filaments. Here's where that blew off at over here. We're getting ejections over here and stuff too that is really small. Now, if we're wanting to see that right there, watch right here. You can see, just let me zoom in again. Sorry. Sometimes these things are hard for even me to see, okay? So watch right here, you'll be able to see it. See it? That's that solar flare CME. Notice where it's coming from. It's coming from almost around the corner there. It's not coming from right here. So, the CME tracker, I think, had it right. I think it's going that way. I don't think it's coming at us. But we've seen the X-rays from it because they go out in all directions, like I explained earlier. So if you look at this is pretty active. Now, this one here is really the one that I think may end up giving us some problems here in the next couple days. Not really problems. I worded that wrong. Sorry. It will be active in that area of the sun, I think. And we got to watch this one too. But I also want to throw something else out there. What I want to throw out there is the fact that we have that phenomenon that they've been doing studies on, that as these things get closer to right in front of Earth facing, a lot of times they dissipate and die off. I don't know if they have very good explanations for that yet, because it seems as though Earth is the only one it does it with. So it makes you question, because if that's an actual phenomenon that happens, you would expect it that every time it lined up with any planet, it would happen. So we wouldn't be seeing much activity hardly at all, ever. Why does it do that when it's just right in front of Earth? That's a question that needs to be answered. And, obviously we're not going to get that answer, guys. They're not going to give it to us if they know. They probably do know. I hate using that word they. I'm sorry. It's just, I don't know what else to say it. How else to say it? I guess I could say pricks or something like that. Who knows? But yeah. So I look for the sun to become more and more active. We're going to start, we're going back into solar maximum. It's going to take us a few years to get there, but it is happening. This is proof of it. We haven't seen a sunspot from the old solar cycle in a while. So I do think we're, they've officially said, yes, we're in solar cycle 25. But there still is an outside chance you can have a sunspot that has that reverse polarity on it. I think they actually would consider that from the other sun cycle, even though we're in this one now. I'm not sure the reasoning behind that, but that is what happens. Something else, I noticed a little ejection up here too. Let's just zoom out one level here. Watch up here. Oh, I hit reset, didn't I? Daggone it. There it is. See it? Watch. Really small, but that's on the North Pole of the sun. You know, we used to get quite a bit of action in that direction, but we haven't seen it in so long. But you can tell just by looking at the outside of the sun that this is something that, let's just do this real quick. Check this out. Let me, well, I got you guys here. Might as well do it right now. I'm going to go over here to SOHO because it gives us okay, this is the same imaging, guys. It's extreme ultraviolet filter, okay, but this is on a different satellite. This is on the SOHO satellite, which is where not Stereo A, but where LASCO C2 is. This one. Alright, that spacecraft has this camera on it too. The one I just showed you came from SDO. This is SDO. Now they're both out in front of the Earth, but they're not in the exact same spot. So, but they do stay geosynchronous. They do stay in geo orbit around the Earth, okay? They stay in the same position looking at the sun always. So if we look at this, this is the sun, like right now, right? 2020. You pull up another one of these. You change the date. Let's go back to, oh, I don't know. Let's go back to 16, okay? Now, compare those two. You guys see what I'm saying here? This one is not as active as this one. You can tell. Now let me go back one more year. Or we can go forward a year even, I guess. Let's go to 17. Okay, you see how we got more sunspots? And how much more brighter this is? Now if I change this one to last year, because remember, we're coming out of that solar minimum. So let's look at it when it was in deep. Look at that. Okay? So that's when we were at the peak of, well, the valley of solar minimum. That's what the sun looked like. This is closer to solar maximum. That's in 2017. So, let's see here. What year did... Hold on a minute. Let me look. So, if we go back to 2013, let's do that. That's in the peak of solar maximum. Oops, wrong one. Look at that. Okay? You guys see that? Now, I know that's why I keep telling people that haven't been in this community very long, understand that some of this stuff that we see is normal. This is normal, guys, for solar maximum. This is what's going to happen again. This is why it's important for us to pay attention, because our electromagnetic field is weaker than what it used to be. So when this sun gets back up like this, we're still going to be weak. Just saying. So anything that blows off the sun there, I mean, look, guys, we counted the sunspots here. I mean, we're probably looking at 4, 5, maybe 6 of them right there. And remember, I was telling you guys about the coronal holes. Look at this big one. It stretches even all the way down through here. That's about half the sun. So my point here, guys, is I want people to understand that. We have to pay attention close, but we have to also understand that a lot of what we're seeing is normal. So what do you guys think about that? You don't think it's normal? Really? Huh. That is 2013 right here. On the right side, 2013. This is 2019 over here. Ellie Oakley, I just curious on why you don't think that that's normal. What's up, Samuel? I'd like to know, because that way maybe I can go look at something and see if I got something I can look at to see if what I'm saying is wrong, because I don't want to be wrong. Oh. Okay. So yeah, I don't know what, I really don't know how to answer that, because the only way I can show you is to show you guys the observations. And something else I could do, I could go back for over 100 years and show you this exact same pattern. Repeatable. Yeah, I got you, Ellie. I agree. I mean, some of the stuff we're seeing is definitely not normal. But as far as the sun cycle and the overall activity, I think is. I do think that we're going to see stuff, and we're going to see, like, bigger Ccme'S and all that kind of stuff. Yeah, it's fine. No, I'm genuinely curious. When people say stuff like that, I really want to know. Because if I'm saying something wrong, I want to go look at what I can go look at and get myself right. That's why we talk. Seriously. How can I show you when we didn't have technology? Because we have Sunspot records. We have historic records of how high it went and how low it went. When I'm showing you guys these, what I'm showing you is the number of sunspots. That's why the sun on the right is brighter. The one on the left has no sunspots. So I can historically go back for over 100 years and show you. Hold on one second. Let's do this. Come on. I don't know why it's not letting me pin that stupid thing. Thank you. There we go. Alright. I think this is worth doing right here, because I think I might be able to show somebody something here. So we can look at this. This right here is the solar cycle. Okay? What I want you guys to look at is this. You see this graph down here? Well, hold on a minute. I can do this for you. Oops, sorry. There you go. That goes back to 1775. Yeah, there are anomalies like that, Mary, for sure. But I guess, let me say this too. You say we didn't have the technology for it, and you're correct. We didn't have the technology back then either to communicate right away. So some of the stuff that we hear from this kind of stuff, what you're talking about, people talking about it, that happened back then too. It's just they didn't have any way to report it. So that's kind of what I'm, that's why I'm showing you this, because if you look at, like, 17, whatever year this is, that would be 1776, something like that. You go on through here, and it most definitely is an uptick, and up and down, up and down. And this is when we're talking about, like, solar minimum versus grand solar minimum. This is what they go and look at. So if you look here in the 18s, okay, was it 1859 Carrington event? I think it was, like, right in here in this sun cycle, maybe. Acceleration in the tilt. I don't know. I honestly don't have an answer for that. I just, what I'm saying is, this is what I'm showing you guys, like the difference between the sun. I don't just have current technology to show you. I can show you historical archived data, and that's what we're looking at right here. And you're right, we didn't have the technology, which is why the communication back then also was not where it's at now. Some of the stuff that we look up, my gosh, that's crazy, when we go report it right away. We got our phones, we got all that stuff and everything. Can we trust those graphs when they're not around, when they were not around then? This is archived data from scientists from back then. They could look at sunspots back here. All this is showing you is the number of sunspots the sun had facing the Earth. That's what this data is. But what that computes to is, when you got more sunspots facing the Earth, this is what it looks like. So my point is that we can't just completely jump straight up into immediate catastrophe, or this is way out of range. One thing I will point out, guys, check this out. Okay, we are in 2020, right? We're in solar cycle. We're coming into solar cycle 25. You guys see the peak on that? See how low that is? Look back here in the 60s. Look how high that was. Over here, it shows you how many sunspots we had. The range is 0 to 400. Our last solar cycle, 24, we had roughly about 100 and, what's it say? About 109 or 17 or something like that. And that's not what that's showing. That's a different number. This is showing you, like right here, that's low. Look at this one up here. We're talking 350, 360. That's a clear uptick. And, what I'm saying is, our sun that's looking like this would probably be 2 or 3 times that bright if we were looking at this year. And I guess where I would land with the, you say, can we, if they didn't have the technology back there, they don't have the satellites, but they had telescopes, they had solar filters. They could look at sunspots. And, I guess where I'm going to go with this is the fact that when we look at this stuff, we have to understand that that's all we got. There's nothing else to go off of. There is no other anything to look at, is what I'm trying to say. Could this data be messed with? Of course. I have no qualms with somebody saying that, because I say it myself with some of the stuff. I do think they doctor some of the imaging. But as far as going back as far as, 1775, just to change some sunspot numbers for 300 years later, that seems a bit of a stretch. That's all I'm saying. Yeah. Yeah, I mean those are all good theories and good ways to live and everything, guys. I really, yeah, Ellie, that's a good thought too. Della, what's up? Jeff? And that's, guys, that's why I try to stick to just like showing you the observation and maybe the data, when I can show you the data, and that way people can make up their own minds and what they believe. I don't want anybody to believe anything that I'm trying to, like, I'm not trying to mold somebody into a specific thought pattern like a lot of other channels will do. You're not going to get that from me. You're going to get complete acceptance of the fact that not all of us are going to have the same theory. So, that's kind of where I stand, And you guys are all making good points in there. Ellie, Mary, everybody's making some good points in there, okay? I mean, seriously. And I do listen, and that's why I asked you earlier if you had like anything I could go look at to try to, help you prove that out a little bit. That's gonna be hard to do that with that. I don't know if there's any kind of data of anything on that kind of stuff. It will be. It'll be extremely hard. Oh, you guys let me do this real quick, guys. This might help. Yeah. Yeah. Guys, that word right there, where I'm on the chat there. Yeah, we all question everything from that. Just saying. And that's the whole thing. And let me say this too, guys. I know that didn't happen in here tonight, people getting mad or anything like that. But having conversations like this is very much like iron sharpening iron. We are supposed to do this. We're supposed to have discussion. We're supposed to talk about this. And we're not supposed to just be so judgmental we can't hear each other. Which, that didn't happen in here tonight. That's not what I'm saying. That's happened on a lot of other things. But we're supposed to be sharpening each other. And I do think that is what kind of happens as we talk about this. I encourage everybody to put any theory that they want in the chat. Everything's been extremely respectful. And that's all I ask. It's that simple. I know that there's people that watch that are flat earthers. I don't particularly believe in a flat earth, but I'm not going to come in here and smack somebody in the head in here for having that belief. It ain't going to happen. I'm going to show you my observations and you can make up your own mind. And okay, Mary. See you later. Have a good night. Thank you thank you for putting your stuff out there, your thoughts, because that's what I want, guys. So thank you for doing that. Some people are afraid to do that, and I don't want you guys to have that fear here. I want you guys to be able to come here, ask questions, put your own opinions in there. We all talk about it like we just did, and wherever you fall after that, you don't even have to tell me. Oh, it's morning, where you at? Across the pond? Excuse me. Yeah, it's about 8 o'clock. Well, no, it's 11 o'clock where I'm at. So, Himalayas. Wow. Awesome. Awesome. So, yeah. The goes? False data? I don't know. I don't know what your question, Nelly. Maybe I can help you. yeah, guys. I mean, and it, I think what is actually happens a lot, and I think that when we're looking at stuff like this, none of us have been here for any of that. So some of the stuff that we're experiencing, some of it didn't happen, and it is brand new, and that's what I'm trying to say. I think we're seeing a bit of both. I think we're having an uptick in certain areas, and some other stuff is just normal. Now, I will say this, that a catastrophe cycle is normal too. So just because it's a catastrophe doesn't make it out of the norm. It just makes it really bad. Okay? And actually that does point us, and it does give us more of a warning, I guess. Magnetic field lines, interaction between other magnetospheres. Oh, you're talking about I know what you're talking about. You're talking about this? Is it false data? I don't think it's false data. I just don't think it's, I don't think the model itself is 100% correct. I think that newer models that we have now, they don't confine it to one line like what you're seeing here. Because that's not actually what it looks like. That's two-dimensional. We live in a three-dimensional world. And that's kind of where I'm at, Hey, MP, what's up? Oh, you said that about 4 times now, Drink. Let me ask you this, Drink. If you know what I'll do? I will, my next show I do, I'll send you a link, okay? You come on my channel with a working model for a flat Earth, and we'll have a discussion if you want to. We can do that. But you're going to have to bring a working model. Yeah, guys, that's, and this is what I'm saying. When we're talking about subjects like we're talking about right now, people immediately get upset no matter what side you're on. And that's what happens. And unfortunately, people get passionate. And I don't want to call it unfortunate. I really appreciate passion as long as it's respectful. And that's where I draw the line at. And I see what's going on here in chat, and I agree with what's happening there, Della. We just got to be respectful. That's it. Yeah, MP. Yeah. And that's the thing. Yeah, it's okay, Drink. I mean, you didn't answer my question, though. You got a working model you can show me? Let's not talk about anything else but what we're standing on. If you can bring me a working model, then I'll be more than happy to, I'll blast it from one side to the other. I'm that open. Yeah, exactly, September. Exactly. Even if it's not heliocentristic, there's still not a working model for a flat Earth. What he's talking about there, guys, is there's a lot of theories out there, and a lot of people think that the sun and everything else in the universe actually revolves around the Earth, and the Earth is the center. You want to know what a coronal hole is? Sure. A coronal hole is simply just, and this is really, really easy. It's basically the atmosphere of the sun kind of peels back or gets thinner, and it allows the particles to leave the sun. Yeah, drink, yeah, I mean, I get what you're saying right there, but I could probably give you a link, and you've probably already seen it, where the community, the Flat Earth community, bought, the one guy, I forget his name, they bought him like a $4,000 high-tech, or like a $10,000 high-tech gyroscope, laser gyroscope, and he did it live, and he showed a 15-degree movement, and he didn't even know what to say. It floored him that much. He couldn't, he directly disproved the flat earth with his own tool that community bought him. So, you know, I don't know what else to say about that. Not to mention the cardboard cutout that another guy had done, where you take a piece of cardboard or a hole or a wood and you drill a hole in it, and then you go down the street or a mile or so, and you do the same thing, and if the earth was flat, you could shine a laser through the first hole, and then it's going to hit the second hole. If the earth isn't flat, it's going the laser itself will be lower, and that's exactly what happened. It showed curvature. That's what that did. Yeah, Tammy, you know, egg earth, pear shape. Actually, the word pear actually describes more of what's actually happening. I don't know, Ellie. I don't have an answer for that one. I really don't. All I can say is that I do trust the model, but I trust it more so what's happening from the front, not so much in the back. I do think that there's stuff going on back here that this model can show. I've done that multiple times. But, you know, I don't know what else to say with the model issue there. It's, all I can say is this model I think it's going on 20 years old. Yeah, you're right. It is. It's extremely interesting. When we start looking at this stuff, I'll grab it so everybody knows what we're talking about here. When you're looking at this, you know, you got your interplanetary magnetic field lines. Now, what I want to point out is this model is making everything a line. Okay? And every line is the same thickness. That's not how it works. Okay, our connection to the sun is, yes, it's magnetic connections. It's interplanetary magnetic field lines. It's lines, not just one. Multiple ones. Back to back to back to back, side to side to side to side, all the way through. That's how the solar wind gets here. The charged particles follow that connection line all the way to us. That's the road it takes. Yeah, the cap lines, the pole lines, yeah, it stretches out. I get it. I know what you're saying there. I'm not saying I disagree with any of that. So we do see weird stuff with that. I just don't have a good explanation for it. And you know, I guess what I'm saying, let me say this first. 99% of the time, when you see this back here get all jacked up, you will see a hit in the front first. Now, if nothing was in the front, and then we started seeing jacked up stuff back here, that would give a whole lot of validity to that. But it doesn't happen. It might happen every great once in a while, But also these tools, as specific as they are, sometimes the little minute hits we get may not show up. And yeah, sometimes every once in a while you'll get a jacked up anomaly back here. You will. And in those cases, that would most definitely be something other than the sun causing that. I agree. And, and that's why, I used to take and look at this thing and try to get real specific with it. But then after I did some research and stuff on it, I realized that these, our interplanetary magnetic field lines and the cap lines, any of these lines, they're not just the number of lines here that they're showing. There are so many more. So many more. And that's kind of where I went with that, Yep, you're right, they do. Hold on a minute. Let me show you something. I showed this one earlier. Okay. This right here is more indicative of what we actually see. This is more so real life what it would look like if we could put a visual on it. There are not straight lines. There's not lines. They're not spaghetti lines, is what I'm trying to say. If you really want to get down technically, they're more like sheets. But, and that's kind of what I'm saying here, Christine, okay. We can do that. You see lines? You're not seeing lines, you're seeing... Let me put this in motion. Hold on. Yeah, Christine, me too. Yeah, we were talking about that parakeet thing. So, that's kind of what you're looking at here. I mean, there's no spaghetti lines. What you're seeing is, what this is showing you on this particular one is the difference in density. It's not showing you lines at all. This is simply the denseness of the particles that are there at that moment. So yeah, I mean, you can even see them waving. It's just the change in density is what you're seeing there. And, Sparky makes a good point, guys. I mean, at some point, where do we cut it off at? What do we do? What's true, what's not? That kind of thing. Or are they lying to us with everything that we've ever seen? Is this, that, and the other? I can't live my life like that. And that's my own personal belief. And the reason why is because we would never have any answers for anything. If that's the case, then, any of us that are doing this research needs to stop and just shut the channels down. Because it's not doing any good whatsoever. And, so yeah, that's kind of, I do question the validity of these sometimes, guys. I do. Any model that I'm looking at that's coming from our government or from any agency that's controlled by our government, any of that stuff, Yeah. Now, I want to say this too, real quick. I still think we get good value out of these models. I think the biggest thing I get from them personally is when I look at it day after day after day, because I do. You kind of get in your mind's eye what's actually looks normal. So when stuff is not looking normal, that's when I know at least something is happening. I might not be able to, do all that. Yeah, Catfish has got a model talking about magnetic stuff. Yeah, he does. He shows you how magnets work and all that kind of stuff. If there were magnets back here, he shows you some of the shapes and stuff that happens here. Some things that kind of happen that look like magnetic reactions, all that kind of stuff. He does. That's what he shows. I mean, he's got some pretty convincing evidence on a lot of different points. I guess for me, it's hard for me to hang my hat on one model. That's all. That's why I don't try to argue with this stuff, because that's what it turns into. It turns into an argument. And nobody ever, I appreciate that you're open enough to actually listen to what I'm saying. And I hope you think that I'm doing the same for you, because I am. I really am. I just, when somebody asks me a question, I try to answer it at least the best that I can. And again, let me go back to this. I think everybody has something to add. I don't care who you are. Do I believe in the moon landing? That's an awful big subject to talk about. I'm not even going to go there right now. That'll turn into some big... Yeah. Man. Ouch. Hey Della, do me a favor. When messages like that are there, just go ahead and leave them there, okay? He could have a different opinion as long as he's being respectful. That's okay. I don't agree with what he said, but that's just, there's a whole lot to that. Huge. Thank you, Della. No, I appreciate you you're doing what you think we should be doing. I get it. But as long as he don't start calling people names and all that kind of stuff, he can put his opinion in there. I want to give everybody the same opportunity, because think about this, Della, and I think if we're trying to get people to understand what our theories are and our belief system, it's better to let people that don't believe in what we're saying and thinking, at least they're going to be able to hear what we got to say. I don't want to cancel them out. You know what I'm saying? So that's the only reason why I say that. I just want to be fair across the board on that. As long as there is no, name calling, vulgarity, and all that kind of stuff. Thanks, Christine. I appreciate that. Yeah. Thank you, Della. You do a wonderful job for me. Thank you. I really do. I really appreciate it. Oh, I don't know about that. I've never even researched that part of it. Backwoods. Oh, the Ccme'S. The Ccme'S aren't going to hit us. They're going the other direction. So yeah. Yes, great mods. You guys are awesome. Hey Ricky, what's up? Sparky, that's a good question. I think, I think I showed this picture before. I'm not going to go grab it right now, but, the shape, what the Earth looks like without water. It's really interesting. I guess I could type it in real quick. We could grab a pic of it. Guys, that's what the Earth looks like without water. Chris, that's funny. Thank you, Ricky. I appreciate that. Honey, she says she hopes you have a quick recovery tomorrow. She said thanks. Yeah, isn't that crazy? That floored me. You know, people don't think about that. You know, I never did. Honestly, I never ever thought that the Earth would ever look like that. But it does. It looks like me when I've been in the water too long, all shriveled up. Good one, Ricky. Earth has a zit. Yep, right there. I mean, it's crazy, you know? It really is. Yeah, you're right, Vitral. Yeah, maybe. Brits, what's up? Yeah, isn't that crazy? I mean, a lot of people get shocked by that. Like, most certainly I did when I first seen it. This is why you hear, like, Neil deGrasse Tyson say the Earth looks like a pear. It's more pear-shaped. Because it is narrower at the top than it is at the bottom. Now, I know most of us, when we look at a pear, it's got a more severe curve. I get that. But at the same time, it's still, technically, that's what they would call it. So, yeah. ISS use radiation pulsar to bring science back. Oh, yeah. That's something I never heard. Like a half-done jawbreaker. Good one. Yeah. Oh, man. Earthquake. Oh, you want to know about oh, yeah. I showed earthquakes earlier, but I'll show it to you again real quick if you're asking. We can look at it again real quick. After this, guys, I am going to get off here. I don't feel good, so my head's pounding. Not a whole lot going on, and that's the problem, I think, in my opinion. I think Dutch did a stream earlier today or last night or something, but yeah. Thanks, Dell. I appreciate that. Prayers for you. Yeah, it's, you know, when we start looking at this and it doesn't look like there's enough activity, you know, Ricky can correct me if I'm wrong. Yeah. Mexicali? Yeah, down here. See, watch this, guys. Change it to all magnitudes and look what's happening. I think that's what Ricky's talking about right there. So, yeah. Thanks, Monica. I really appreciate it. Yeah, that, you know, guys, this is something that... That's okay, Anita. Thank you. Could be, Ellie. Could be. There's a lot of, you know, down this fault line, we all know that's always active anyway, but when we start seeing swarming, that's really, we're like, hey, you better pay attention to that. Because no matter how big or small the actual swarming is, it just, you know, these are almost always precursors to bigger ones. Yeah, it's a volcanic area. That's the other thing I was getting ready to say. You know, then that's just a whole nother issue to unpack, you know. I do think, and people can correct me if I'm wrong on this, when we have like a volcanic, you know, eruption, I think they consider that like seismic activity, don't they? I'm pretty sure. Because it is pretty much all the same system. It's all tied together. Thanks, Ellie, for saying that. I appreciate that. Yeah, I think that's where, you know, Ellie, you make a good point. And it, you know, things have gotten to what what everybody, they put a name on it, guys. It's called cancel culture. And, I don't think anything is ever solved by that. The institutions that we hold in such high regard, even when it comes to our religion and stuff, everyone across the board has used all that stuff at some point in time in history as a negative thing. You can point to any religion and say that. A lot of times stuff that gets pointed at at a Christian would be like the Crusades and stuff like that. I think with Islam, I can't remember what that one was. There was like an event that happened, but there's every religion has its good and its bad end of it, and a lot of times some of it just gets misinterpreted and misused for nothing more than just trying to control the public. So that's what happens, I think, a lot of times. You'll never forget that image, Peggy. What, the one, the pick of the earth? Yeah, that's a crazy one, I have to say. It really is. This one? Yeah, you guys can scroll down through here because this is just looking at it vertical, where Africa is. Let's do this. There that is again. Here, look at that. That looks more like a pear, doesn't it? That's the other side. That's the Pacific Ocean, I think. Yeah, I think that's the Pacific. Yeah, it is. Don't get scared over that. I mean, it's been like that since the beginning. Okay, okay, now I'm going to go into something here just for a split second. I'm not going to go too much into it because I am going to get off here. But when you put the water on this, and there's a whole lot of things that we can talk about, why the water goes where it goes, how it's held there, all that kind of stuff. If people don't know, there's something called the equatorial bubble. There's more water on the equator. And I'm not going to go into the science behind why. It has a lot to do with magnetics and our rotation speed, all that. So the key word there was magnetics. So when we do either go through a magnetic pole flip or a magnetic excursion, any of those kinds of things, the theory is that equatorial bubble will release. So what does that mean? That means that water's got to go somewhere. Where's it going to go? Well, guys, what that means is that every coastline in the world will flood. That's what will happen when that happens. When the magnetics release, when it depending on how fast it does it, I don't know if it would be a slow release or if it would be an instantaneous just woof. I don't know. Spinning centrifuge. Yeah, that's part of the science behind that. Thanks, Elizabeth, for the advice. Appreciate that. Mark, good to see you. Have a good night. All right, guys, what we're going to do, I'll do this. I got somebody I tried to give all the science and all the information first before we started having our chit-chat. That way people could not listen to it if they don't want to. But what we're going to do here real quick, if everybody can hang out here for a minute, I want to... And I feel bad last night because I didn't hang out with Mark too long because I just wasn't feeling good at all.
Hate to be one of the other four.
I think he's doing a Harry Carey thing there. That's what it looks like. Let me push play. You guys can listen to it for a second.
So hey, Tony. Where do you go from here, Tony? You've been on the cover of Real Estate Mogul magazine as the most successful realtor in 2009. What are you going to do? Where do you go?
Anyway, guys, I'm going to give him a like there. This is Mark Pyers. You guys know him by now. If you don't, please go over here and subscribe. Follow me over there. We're gonna love bomb him. If you want to go, guys. If you guys want to go do that with me real quick, everybody just leave my stream. Go straight over there. Even if you only stay for 5 minutes, please come over there and give him a subscription. Give him a like. Say hi from Wages World. You don't have to say that if you don't want to. No big deal. But let's everybody do that, okay, guys? So God bless. Yahuwah saves.